Hello, College Prep Math 1 at Shasta High School. This is Mr. Roberts, and we're going to be looking at the Chapter 8 Study Team Test. This was the test that we took in class last Thursday together with our study teams. This Friday, I think on the 22nd, you'll be taking the individual test that covers most of this material. So we're going to go through and look at kind of detailed leisurely solutions to each of these problems in an attempt to help you prepare, maybe fill in some gaps, things you don't understand, so that you're maybe better off and can do better on Friday. Question 1 is, it says solve the system of equations. There's two of them, one in part A and one in part B. You may use either substitution, elimination, or the equal values method. Your work must be neat, clear, and easy to follow. The thing that I love about part A is it's perfectly set up for elimination. Remember, in elimination, if you look at this, I've got a positive y in the first equation and a negative y in the second. The whole idea here with this elimination method is if you have things that are equal and you add to each side of that equal things, you end up with equal things. And if we have a situation where our y's or our x's are opposites of each other, when we add those equal quantities together, either the x or the y will eliminate, right? That's elimination. So if you look at this, you can see that this first equation tells me that 2x plus y is equal to 15. The second equation says 3x minus y is equal to 5. Since these are, equal things, this is equal, and these things are equal. If I add the first group of equal things to the second group of equal things, it will result in equal things. Now over on the right hand side, 15 plus 5 is 20. And on the left hand side, when I combine a positive y and a negative y, that's just 0. So what my left hand side ends up becoming is 2x plus 3x, which is 5x. And now if I divide both sides of that by 5 rather, I'm anticipating the answer. I get that x must be 4. That's acting a little silly. X equals 4. So right off the bat, we know what x is. Now it's just a matter of figuring out what y is. And it doesn't matter which equation we could use. We could use either the first equation or the second equation. I'm going to choose the first equation just because y is positive, but I'm going to just rewrite it. First of all, it says 2x plus y equals 15. And of course, we know that x is 5 at this point, or 4 rather. So I'm going to plug in that value of x into that first equation. Again, what we're looking at here is I just rewrote the first equation, 2x plus y is 15, and I'm plugging in that value of y. This will become 2 times 4 plus y equals 15, or 8 plus y is 15. And when I subtract 8 from both sides of that, I end up getting that y has to be 7. So you can see we know what x is, we know what y is, so our solution is the point x 4, comma, y 7. So the solution point is 4, 7. That is the point that will make both of those equations true simultaneously. And just it's worthy to look at, right? If I take these values and I plug in, right? If x is 4 and y is 7, notice 2 times 4 is 8, plus 7 is 15, so that checks in the first equation. 3 times 4 is 12, and 12 minus 7 is indeed 5, so it checks in the second equation. So this is definitely the solution. It's the point that makes both of those equations true. Let's take a look at part B. There's a couple options there, and I'm kind of tempted to think about this in terms of elimination again. If I was to, and I don't think I'm going to use this technique, but one thing I could do is I could multiply both sides of the second equation through by 8. If I did that, that would become 40x's and then negative 8y, and over here it would become a negative 24. And actually, now that I've done that, I think I'll go ahead and finish it that way. I was going to isolate y in the second equation and then use substitution. But I like the look of that elimination. So let's think about it. The second equation, Again, if you have equal things and you multiply both sides by 8, you're going to get equal things. So I'm going to rewrite the first equation. The first equation is, well, let's just do this multiplication first. So 8 times 5 is 40x, and 8 times negative y is negative 8y, and 8 times negative 3 is a negative 24. Now, I'm going to now take that second equation, I'm going to write it right below that, so they're right near each other. So that first equation was 3x plus 8y, and that equals a positive 24. So now if I go ahead and combine these, again, I'm using elimination here, I end up getting a 0 on the left-hand side, right? Negative 24 and positive 24. The other thing that happens is my y's are completely gone because I've got negative 8y and positive 8y, so that's a 0. And then 40x plus 3x is 43x. And don't despair here. I've seen some of you on your study team test decided, well, there's no solution, and you moved on. But actually, if you divide both sides of this by 43, right, 0 divided by 43 is 0. So we can clearly see that x must be the number 0. So we know what x is. And now that we know what x is, we're going to figure out what y is. And I think you can use either equation. I'll use that first equation. That first equation is 3x plus 8y, and that equals the number 24. X is 0, so I'll go ahead and plug that in so that this becomes 0, and I'm left with just 8y equals positive 24. And if I divide both sides of that by 8, we get that y has to be 3. Again, this isn't a solution because I say so. It's a solution because when I plug in 0 and 8 into both equations, it works, right? It makes both of the equations true. So 0, 3. So just to be clear, let's take a look at that. If I plug 0, 3 in the first equation, if I plug in a 0 for x, this becomes 0 plus 3 times 8 is 24, and on the other side it is 24. So you can see that that totally is a solution there. And on the next one, same thing with the 5x. If I plug in 0 to that, I get 0 minus, and then you can see the y is 3. So it's a minus positive 3, and over on the other side it's negative 3. So it makes it true also. And if that didn't work, right, I would have to start looking carefully at all of my steps and try to figure out where I made an error, because a solution to a system of equations must make both of the equations true, and an equation is true if the left and the right hand side are equal to each other, because that's what an equation is. It's a statement of equality.